Notepad? No, Notepad. If you declare a string like this, name equals Bob, right? It would be really neat if we could do this. Name subscript 0 is equal, C, and then later on, if we printed out name, it would print out Cobb. That would be cool, but it doesn't work that way. We cannot change a string once it is created. I'm sure that there are really good reasons for that, but there are some consequences to that, meaning that each time you build, you add something onto that string. Like if you did this, name equals name plus, and then you tacked on that guy's last name, Bob Roberts. It has to not just append this word to that one, but it's got to allocate a brand new string that's the size of both of these things put together. And then it's got to hope that the garbage collector will come along and release that memory, at a reasonable enough rate, which is fine for moving individual, pieces of information around. But if you have a loop that's running hundreds of thousands of times and it's manipulating strings, or the string is getting longer and longer and longer, and each time it needs to allocate a new chunk of RAM and then release it and allocate it and release it. Whereas the string builder, since it's a class, it keeps track of the string in its own internal memory inside that class and is not immutable. You feel like changing the first character in it? You can do that. You feel like inserting something into the beginning of the string? No problem. It doesn't have to keep allocating larger and larger and larger blocks of memory and then hoping the garbage collector will come and free it up. So we're going to write something that's going to create kind of an absurd string. Something that's, 100,000 elements long. And you don't have to type this. Not a specific lesson. I'm not going to ask you about it on an exam. But it's worth knowing that the string builder exists and having a clue about it. So that's why we're going to take the time. I don't even know what lecture we're on.
Jay?
Sounds good to me. All right, so I'm going to write an itty-bitty little loop that adds something to an empty string, and then we're going to print it out afterwards. We're going to add like 10 numbers to a string and print them out. So I'm going to declare my empty string, and I'm going to call it S for simplicity's sake. String S equals quote, quote, semicolon. Now I'm going to write a loop for parentheses I int space I equals 0, I is less than, and let's go 100 times. I plus plus S equals S plus string dot format quote %d end quote comma I. So convert it to a number, tack it on to the end of the string. Excuse me, convert that number to a string and tack it on to the end of the string. There's probably another way we could do that. How about we do this? Integer dot to string parentheses I. We're going to take that string, we're going to take that number, we're going to convert it to a string, and we're going to tack it onto our current string. And instead of saying S equals S plus, we're going to write it in our more normal way of writing that. S plus equals integer dot to string I. And then let's printing out the string. Yeah, let's go ahead and print it out, but then we're probably going to take this out because we're going to change it from running instead of just 100 times. It's going to run, 1,000 or 10,000 or 100,000 times. But anyways, I'm kind of curious what the string looks like. It's just going to be a series of numbers, 1, 2, 3, 4, 5, 6, 7, and so on. Come on. There we go. Right. So I don't think that we need to print the whole string itself, but let's go ahead and print a message. Print done with string, length equals, end quote, plus s dot length, parentheses in parentheses, like that. All right, so it processed 100 times. The string wound up being 190. It ran lickety-split. We can't detect any slowdown there. Hey, everything's pretty cool. What if we change this to 100,000? 5 zeros after the 1. 2, 3, 4, 5. That's taken a considerable amount of time. We can't even tell how long it's taking. We want some kind of intermediate printing to go. Like, you know, when you run something and it's got a progress bar so that you can pretend to have some comfort that eventually it'll finish running. We need some kind of progress bar in here.
Divided by 10 instead of 1, 2, 3, 4, 5, 7, 9, 10.
Yeah, we're going to print out like a dot every 1,000 iterations or so. So exactly. So if I modulus 1000 equals 0, in other words, if it's evenly divisible by 1,000, system.out.println I, just so that we can watch those numbers increase. Better make it a progress bar. We'll see scrolling numbers, but that's okay. It's taking it longer and longer and longer to do. What would also be interesting to think about is how long the string is at each one of those points. So I'm going to close it. And after the I, print line I, I'm going to print line I plus a space, end quote, plus s dot length, just so we can see how long the string is at that point in time. So the string's getting longer and longer and longer.
Professor?
Yes, sir.
He had his hand up.
Oh, I'm sorry. I ignored you. What's up?
Sorry.
No problem. Two equals signs right here. What's the error say? Closing parentheses expected. Makes me think that there's a closing parentheses expected up higher, but, oh, I put a plus sign. Yeah. Cool. So eventually, it was finished. We can rewrite that to use a string builder. And to make sure I get the syntax perfect the first time, I'm going to go ahead and look at my little notes.
Sure seemed like a long 24 seconds. Because we're used to instantaneous responses.
Yeah, it took it 24 seconds. We could put a counter in. We could start a clock, you know, and then collect the time at it. And if we were going to do fine-tune performance measurements. In this case, it's so obvious that the performance is slow that I don't think we need to do that. So how about above this code, we go ahead and use a string builder instead. The string builder is much faster, so I want to do it first. So string builder, capital S, capital B, string builder, I can't type, string builder, SB equals new string builder. And we're going to kind of repeat this loop here. For parentheses, int I equals 0, I is less than 1 followed by 5 zeros, semicolon, I plus plus. Why am I getting an error? Oh, got too many closing curly braces. SB.append integer dot to string with a capital S, parentheses I. And when it's done, let's print out that we're done with the string builder. System.out.println, parentheses quote, done with string builder, length equals plus s.length. Open parentheses, close parentheses, close parentheses. That's too long of a line. I'm going to break it into 2 lines on my screen. That is correct. That's not right. We need to get the string. So how about SB dot SB dot, okay, I'm completely rewriting that. SB dot to string, parentheses in parentheses, dot get length. Not get length, just length. Now I didn't put my little interim counting in here because I'm expecting it to be so fast that we don't even really need it. And that is in fact the case. Did you see that? It got done with this one immeasurably more quickly than the rest of it. If we put a timer in there, then well, you saw it. It's taking 24 seconds to add 100,000 elements to this string, and it did it in a split second, a couple of milliseconds, something like that for the first one. Why is it that much faster? It's faster because it's not having to allocate and release and allocate and release and allocate and release more and more RAM as it's going along. So the string builder class is, pardon me?
So what does the string builder class do then?
It's a high-speed replacement, more flexible replacement for strings,
Okay.
right? Because if we were going to append something to a string, it's like every time I wanted to, oh gosh, my examples are always so stupid.
So like if you're trying to deal with the runtime on something, you would use a string builder instead of a string to cut down on the
Right. If you have a loop and you're manipulating a string, you're trying to append it or change its contents, and it's looping a lot, then each time you change that string or you create a new one, it's actually allocating more and more RAM to do that, and you never know if the garbage collector is coming along fast enough to release it or not, and the memory requirements of the program are going larger. So if you have a string that's being modified in some way over and over and over, you want to use a string builder because it just uses one piece of memory and actually makes the changes to it. Yeah. So if we look at the string builder class, take the easy way out. String builder examples.
I feel like that's that's the case for most programming languages. You teach by going on Google and looking it up.
Exactly. Yeah.
I feel like in the field you have to do that yourself anyways.
You do, right. So, append, we've seen that. Append is the one with the most astonishing clear-cut performance gains. And Java now tries to cheat. The compiler, if it detects that you're doing an appending act in a tight loop, it tries to substitute some calls into the string builder class to perform it. But it doesn't work very often. We noticed it not working here. If it did, then we wouldn't see the other loop being so much dramatically faster than this one. So we can't depend upon Java optimizing it for us. That's why we want to use it. So we have the builder, the append method. How about something more interesting than appending? Okay, fine. I'm just going to go back to my editor and type SB dot and get a list of methods for it. SB dot. We could append. We can get a character at a specific place. That's just like using the, dot get. Delete. You want to remove something from the middle of the string. You want to delete, positions 20 through 30. Then you would call SB dot delete. and specify those values, and you know that they would be removed from the string. Insert, you can insert into the middle of the string. We were appending, but we could have used insert. I'm not sure if inserting into the beginning of a string has even more performance drawback if you use pure strings or not. I don't think it would. I don't think it would matter because it's having to create a brand new string no matter whether you're sticking on the end or the beginning each time. And then getting substrings out of it. You know, some of this stuff's available in the string, of course, obviously. If you want to pull the substring out of a string, you can do that. You want to get the length of the string, you can do that, but you cannot call replace because the string is immutable. You cannot call insert into it because the string is immutable, meaning it can't change. You can't call .append because it has to create a brand new string to do so, and the string builder lets you have all that. So it's a far more memory efficient thing to use, and our programs have not been. We don't write loops that run millions of times, you know, modifying strings, so it hasn't been important to us to do that. And from now on, I am going to teach it. All right, my guess is that there are some folks who wished that they had this up and running. So, pause. There are a great many other collections other than ArrayList, stacks, and queues. One of them in particular, or some of them in particular, are very important, but we're not going to hit them right now. Can we find a great big map of them? So here's ArrayList way down here where you can't see it. Here. There's also tree set and linked lists and stack. A stack is apparently a form of, I wish I hadn't set this background black. That makes it harder to see. So array lists are inherited from something called an abstract list, which is inherited from something called an abstract collection, which is inherited from the collection class, which inherits from the iterable class. I should not use the word inherit anymore. That's more C++ term. Extends is the term that Java decided to use. So the array list extends the abstract class list, which extends the abstract collection list, which extends the collection type. And then a stack is a very specific form of vector, which is also another form of abstract list, and so on. And each one of these has some different, different specialty.
I have a question.
Yes, sir.
Is it inherit from that one that has like a father class or something like that?
Yeah. This is the root class. They call different books call them different things. In Java, it's called the base class. So that's the base class of them all. You could also say that this is the father of this class, and this is the child of that class. ArrayList is the child of the abstract list class. It is the subclass.
Maybe I'm remembering it wrong. I feel like there was another one that was legitimately called inherit because in Java.
C++ does
But
inheritance, and Java does inheritance. It's called inheritance. It's just that the keyword you use is extends.
Really?
Yeah.
Because I remember when I learned this in high school, they always said inherit because it was something like the parent or I forget.
Right. Inherit is the computer science term, and so they go ahead and use it, but then they did not choose to use that keyword for some reason. I don't know why. It's extends. So we could make a class, and then we can add things onto it, more functionality. Each one of these is getting ahead of myself. If we wanted to implement a queue, if we wanted to go ahead and do our own, use the official queue, I would use the priority queue class since it's already written, just like I would already use the stack class since it's already written. Some of these things are not thread safe, meaning that if you have multiple threads running at the same time, adding to the same collection type, then it could be unsafe. What does that mean? What if you have two threads running simultaneously, and nowadays every computer you have has multi-processing chips inside them, like dual-core chips or four-core chips or whatever. They both can be running with different threads, different processes manipulating the same data. What if they both need to add onto that stack? Well, if the stack class is not thread safe, it means that when they both access it, then the memory can get corrupted as they both try to write to it. It doesn't do the locking of the memory correctly, right? It doesn't say, okay, hey, the stack is mine right now. You need to wait until I finish writing it. And then, oh, now I can release it. So if we Google up thread safe stack Java, if a data structure is not thread safe, then you can end up having race conditions when the correct execution of code depends on the sequence and the timing of the threads. If things are accessing the stack one after the other, by pure circumstance, it may work, but it's not always going to work. So there are ways you can get around that. There is a locking mechanism used for multi-threaded applications where you can say, okay, this piece of memory is locked until I'm done with it, and then I'll release it. And as long as the other application, the other thread has been written to respect that, then they can cooperate and they can handle it. All right, and this is saying that the stack class is now thread safe. That's news to me. But the documentation goes ahead and suggests using ArrayDec. Hence, we won't get into too much detail. Although the Java stack is thread safe and straightforward to use, there are major disadvantages. It doesn't have support for setting the initial capacity, and it uses locks for all operations. This might hurt the performance for single-threaded executions. So the stack class is automatically handling that problem of multiple threads trying to access it at the same time, and it's doing so in kind of a hard-nosed fashion. Every time it tries to write to that memory, it issues a lock on the block, on the block of memory. It goes ahead and writes to it, and then it releases the lock, which is great if you have multi-threaded applications. Now, we haven't written a single multi-threaded application since we started taking Java courses here. So we are suffering performance degradation by doing that, by using this class over something that only starts locking when you actually have two threads doing it. Now really, I thought that the stack class wasn't thread safe and that the recommendation to use dec was based on that, but apparently that has changed. All right. We will work with the idea of threads and processes, having multiple threads inside your process at a later point. Yes?
I was wondering, are we going to do a review today? Like of this,
Yeah, we should do a review. You're right. We should. Your best review is just to redo the quizzes, but I will look through the test and do some review.
On the quizzes, when we go back to them, can we see like our previous answer?
Right, you can. Let's make sure that we all know how to do that. And if you can't, it's a problem. I need to be told about it immediately. If you go in, you click on your quiz, you do the pull down, it'll say submissions, and then you'll have a list of submissions, and you can click on one of them and see each question, whether you got full credit for the question or not. Is it working for everybody? Did this last time. Yeah. Okay, good deal. You're the one who asked, so I'm not sure. Right, so like, yeah, one of your quizzes.
So if I go back to this one,
Okay, go back out. Yeah, and click on the little down arrow, the chevron, the thing next to the name, and click submissions. And then you can click attempt one, and it'll show you.
okay.
Yeah, so I need to absolutely make sure that everybody knows that, because otherwise, why are you taking the quiz, right? I don't use a quiz for a grading tool, although you do get some grade for it, but as not as a measurement tool, but as a learning tool. And the reason I do that is because I want you to be able to do it over and over. So you click on the little down arrow next to the quiz name, you choose submissions, and then you can see each time you took it, and you can click on that and see each individual question and whether you got it right or not. So let's play with the idea of inheritance. We're going to write a silly class, and it's just going to have one data element, x. And then we're going to create a class that inherits from that one that adds another data element, y. And then a class that inherits from that one that adds one more data element. So up above my public class lecture J, I'm going to make a class called, I don't know, P1. And it's just got an integer x in it. Then I'm going to make a class P2 that inherits from P1, that extends it in the Java nomenclature. Class P2 extends P1 int y inside the curly braces. Class P3 extends P2. Extends P2. Type in all caps, please. No semicolons there. All right. So P2 is the parent class for P3. P1 is the parent class for P2, which effectively makes P1 the grandparent class for P3. Other people use the terms root class and subclass. My brain is glitched and I don't particularly recall which one the book wants us to use. If we do make them public, then the program will not compile. We should be putting them each in their own file. That's the correct way to do it. But inside a Java file, there can only be one public class. And so the side effect of us doing it like this is that if we had another Java file in the same project, it would not be able to access any of these classes. So each one of these should be in their own class. It's just so much easier to be able to show that if we don't. So how do we use our cute little classes? I'm going to condense them just a little bit by doing that for now. You don't have to do that. And I'm going to comment all this stuff out because, no, I'm going to leave it alone, but we're just going to have to watch it do that stuff every time we run it. Maybe we could move these numbers 100,000 just down to 1 so that it doesn't take any time at all to complete those. Okay, so back up here, I'm going to make an object P1. P1 Bob equals new P1 parentheses in parentheses. Bob.x equals 10. Now, Bob doesn't have a y value. Bob.y is equal to 10. That's an error because the P1 class only has an x. So that didn't work. Let's make another object. P2 Sam equals new P2, parentheses in parentheses. And now Sam.x is equal to 10. Sam.y is equal to 20, something like that. And again, we don't have a z because the P2 class, although it has everything that P1 has, it doesn't have anything else. Whereas the P3 class is going to have everything that P2 had and P1 has. So let's create one more. P3 Jack equals new P3, parentheses in parentheses. Jack.x equals 10. Jack.y equals 20. And Jack.z is equal to 30. So a subclass, a child class, has more than the base class. The base class is often called the superclass, but it's not super. It's just above it in the hierarchy chart. It has less functionality than the things that inherit from it. So let's go look at PowerPoints for Chapter 13. Stop that. So far, all of our objects have been relatively simple. We've been able to describe each one with a single class. But for an object that's more complex, you may need to consider breaking an object up and defining one class as a whole, and then the other classes as parts of the whole. So for example, if you're writing a graphics program, you might have a class called point, which represents an XY coordinate on the screen. And then you may write a triangle class, and it has 3 points. Well, that class is making reference to another class. So the human body, it's got a brain, it's got a heart, it's got a stomach, it's got a bone. So each one of these would be classes. And then our human body class would have these as variables. So we would have a brain variable, a brain object, a heart object, a stomach object. And then in the meantime, muscles is based on cells, and cells have all these individual components. So this is a has-a relationship. Car has wheels. Body has brain. Now that's not inheritance. This is not an example of inheritance. This is all has-a relationships, which is known as aggregation. Composition. Aggregation is a slightly weaker form of composition. Right, so the human body has a stomach. The human body has muscles. Each muscle has cells. Every cell has a nucleus. Every cell has a mitochondria, and so on. inheritance is an is-a relationship. A car is an automobile. A brain is an organ. A cat is a mammal, which is an organism. So composition is one way that classes can be related. It's just that one class has variables of that other type. And then there's inheritance. Like this, we have a person class. It's a generic class that all it has is somebody's name. And then we have a customer class. A customer is a person, and also every customer has an address. Then we have an employee class, which extends, which inherits from the person class, and it adds on something too. It adds on an employee ID. Now apparently employees don't have addresses. So, these are considered two different branches. And then down here we have full-time employees and we have part-time employees. A full-time employee has a salary. A part-time employee has an hourly wage. And so every full-timer has a salary, an ID, and a name. Whereas every part-time employee has an hourly wage, an ID, and a name. So when we look at this textbook wants us to use the term superclasses and subclasses. This is a superclass. It is a superclass for the customer class and in the employee class. Now it's not called a superclass because it's at the top of the list. It's just that he has a superclass and he's got some subclasses. This guy is the subclass of him. He is the subclass of him. He is the superclass of that one. That is the superclass of that one. Now in this language, unlike C++, you can only inherit, you can only extend from one class. Meaning that he can only extend that one. We can't have an arrow also going here saying full-time extends both employee and customer. And that's probably really a good thing. There are other ways to implement something. If you need to, quote, inherit from multiple classes, then you use another keyword rather than extends. So the term superclass implies that it's more powerful, but it's not, right? He has the least amount of data at all. By the time we get down here, every full-timer has 3 bits of data: salary, an ID, and a name. Whereas the root class, the superclass of all of them, has just that. Now everything we implement, although we don't see it, inherits from the object class. And the object class gives us a .equals method and a .toString method, and neither one of those do anything useful, so quite often we wind up overriding them to create our own. All right. I need to slow down just for a sec. It instead uses the idea of array lists and two-dimensional arrays. And I thought I'd already unlocked this. Did I post the instructions out for it and just not have the folder ready? Let's look. Yeah, the array list and the 2D array. So what does this program do? It generates a series of points, adding them to an array list. So we're going to have an array list. And each point, is going to have some random value in it. It's got an X value and a Y value and then a Z or something like that. And so we're going to generate, like here in this case, we generate 5 random sets. So like the first point add the values of at x7, whatever. And so it creates a certain number of points, adding them all to the array list. The array list gets longer and longer and longer as we add points to it. And then when that part of the cycling is done, we've created our array list of points, and the point, let's just have an x and a y, and a z thing. Then we run through the array list, pulling that data out and setting those values on a two-dimensional array. So your program will, at the end of processing, display a 40 by 40 array of numbers in a grid format, a two-dimensional array. And randomly selected positions in the array will contain non-zero values, randomly generated between 1 and 9. And yes, you've written things that generate random values, and you could just fill an array with random values, but that's not what this one does. This one wants you to feed random values into an array list, get your array list ready, and then pull from that array list, or it could have been a stack, in order to populate the 2D array. And so the values will be initially stored in an array list. Once the array list is done, then they will go into the two-dimensional array for display. So we will need to generate 40 random points to add to the array list, and then we will process those 40 elements of the array list, setting their coordinates in the array. So we would want to create a point class that has an x, y, and a z integer thing. And then we would want a two-dimensional array of ints called our map. We're going to create 40 point objects where x and y are random numbers between 0 and 39 representing coordinates on the map. Like this is a coordinate 16, 8. This is coordinate 29, 3. And then the last value is a number between 1 and 9. So each time you create one of those objects, you're then going to append it to the array list. By the time you're done, your array list will have 40 points in it. Then the next thing to do is to iterate through the array list to process all the points. So each point does have randomly generated data in it. And so what you do is you have a for loop for each point in array list. For p in array list, modify your map, right? So that p.x subscript p.y subscript is equal to p.z. And then display the array. I do have a help file for this, I believe. Let's go take a look. Here's a random number generator, which you don't have to use. You know how to generate random numbers on your own. You absolutely don't have to use that. But if you needed help making random numbers, then you could use this little bit of source code. However, we've been using random numbers along the whole time anyways. Let's look at the help file for this. One time, this is assignment 3. It's more ambitious in those days. So we're going to need a point class that has x and y values for coordinates and a z value that contains the data. So what do you need? You need a point class, you need an array list of point objects, you need a two-dimensional array. So here's a sample point class. And here's a two-dimensional array. This one's a 10 by 10, but this one actually wants 40 by 40, but you could write it to be 10 by 10 first and then go from there. And here's making an array list of points once you have that class. And so you have some code here that would seriously cut down on the amount of thinking you have to do to get this one right. I don't care if you use a help document or not. Totally feel like using the material provided for you if you want. Or if you feel like roughing it for a little while and then looking at it, that's also totally cool. If you feel like doing it all on your own without even ever looking at the help document, that's totally cool. Alrighty. That make sense? Sorta? Yep. Yeah, I see some sort of. Pardon me?
It will when we get in it.
Right, you're going to have to read it again and read it again.
Glad you explained the third element. I was going, huh? Three-dimensional grid.
It's not a three-dimensional grid, but in a way it kind of models it, right? If you thought of each one of these as being height, right, this would be a mostly flat plane, except here this has got an altitude of 8, and this has got an altitude of 4, and this has got an altitude of 3. But it's a two-dimensional array of values, and the values each have an x and a y component, and then, so 7, 9, 3, if we count it out, 7 rows down, 9 over, you see the 3 there. So, things that would be good to know. True or false? Can a class have more than one constructor? Yeah, sounds true. True, false. A class is defined of type void. Excuse me, a constructor is defined as type void. No, that's not true. Because what is a constructor? A constructor is a method that has the same name as the class, no return type, and is called by the new operator.
Is no return time not the same as void?
You would think, but no. I can't explain the difference, honestly. But when you define a class, like if we have a class called point, we would do this, public point, and it takes an x and a y. It doesn't return void, it actually returns a point in and of itself. So I think to shorten the syntax from having to put that, which looks a little bit silly, I think they just said you leave that off. Yeah. Does Java give me a constructor if I don't put one myself? In other words, do I have to put a constructor in every class I write? No, because it gives us one by default. If I do put one in here, does Java keep giving me the default constructor? No. Once I add a parameterized constructor like that, if I still want to keep using the default constructor, I have to go and add it again myself. And some of these are so straight from the quizzes. Like if we had this class point, and it had a double F. Now write a getter for it. We could write a getter for it. What type should it be? Well, let's make it public. Let's just say that we're writing a getter for F. What's another fancy term for getter? Accessors. And then setters are mutators. So, a getter for F, what would be a good name for it? Let's call it getF. What does it need to return? Well, what type is F?
Double.
So it needs to return a double. Does it need a parameter? No, because we're getting, we're not setting. And then we would return this .f. A setter, right? Also public, but it doesn't need to return anything. You could make it return something, but traditionally you don't. What's a good name for it? Well, we're setting F. But we do have to pass a value in, right? Or else we're not going to be able to have anything to set. So double F, and then we, inside our curly braces, this dot F equals F. So if we had a point class that had this, one of the questions could be, write a constructor that will set F and G, right? If you have more than one method with the same name, what is that called? Yeah. Or if we're going to play Jeopardy, answer in the form of a question. What is overloading?
If you put our test in the form of a method.
So if you have, broadly speaking, two types of things. You have instance members and you have class members. Which one of them do you use a static keyword to define? Class members are known as static. You use the word static to why didn't they just use the class keyword? Or I don't know. Anyways, instance members are the non-static ones. Class members are the static ones. So if you had this class, class P, and it had two variables in it, which one's the instance member? That one is the instance member. This one is not. That's the class member. What does that mean? To access this, you have to have an instance of the class. I have to make a new point. P Bobby equals new P, and then I can get a hold of X, like that. It's an instance member. The class one, though, I don't create an object to access it. I just say P.Y. Notice, oops, that was a mistake. It's not P.X, it's Bobby.X, because that's the name of the class. That's the name of the object. So the instance members are the attributes of it, right? A car has 4 wheels. Each wheel would be an instance, right? Every car, this car may only have 3 wheels. It's a different instance of the class. Whereas ones that are defined as static apply to the class as a whole. You could say that every object shares the same, but really it exists outside of the class. In other languages like the C++ programming language, you'd call it a global variable. Right? It exists entirely outside of the class, and you just get to it via the class name. So, for example, all the math functions are defined as static, so that you don't have to create a new math object in order to use them. So you can access them with math.pow and stuff like that, right? You can access them without creating an object. On the other hand, when we use a scanner, do we create a new scanner before we start using it? Yeah. So that means that those are instance members. We create a scanner before using it because its members are instance members. So all the math functions are defined as static, making them class members, class methods, class functions. So if you can remember that instance members are non-static and class members are static, I could lecture about that 4 days in a row and it will still escape people's minds because it's that abstract of a concept. That's not any slight on y'all, it's just a weird concept. If they'd chosen a better keyword than static. So what is an instance variable? Is an instance variable defined outside of the class, or inside of a class, or inside of a method inside of the class?
What were the options again?
Yeah, what are the options? Yeah, let's just put this like this. The difference between an instance variable and a local variable. Which one is defined in a method?
Local variable?
Local variables are local to specific methods. The instance variable are defined in the class. And there's no way you could define a variable that's outside of any class in this language. So instance variables are defined in the class. Local variables are defined in functions, in methods.
And they're the same as static?
No, none of these are the same as static.
Pardon me? Neither one is?
Static variables are also defined as part of the class. So instance variables and static class variables are defined in the class.
I can't really static what inside the local.
Right, in this language you cannot. C++ being the weird beast that it is, you certainly can. So if I gave you this, class boo, int x, and it's got a function, which one is a local variable? Say it out loud so we can get to the next question. That's the local variable because it's local to a method. So x is part of the class, but it's not local to any particular method. And do we think that this is a class or an instance variable? Instance means non-static. So that's definitely an instance variable. If you have an array list named Bob, how would you print them out? With a for loop. I don't know, something like this. You could do it two ways. You could use a counter or you could use a for each loop. So for int I colon Bob in parentheses, print I. Now obviously that's not Java, right? It'd be system.out.print line I, something like that. But it's getting in the right direction. Don't give me this answer. Go ahead and use the whole word system.out. All right, there we go. Right, like that. What if it was an array instead of an array list? It'd just be that easy. You would just change the name of this variable. That's what's cool about for each loops is that the syntax is very similar despite whatever the collection is. All right, if you have an array that's 10 elements long, what's the lowest index number of it? What's the lowest position you could access? Yeah. If an array is 20 elements long, you can access elements, index values, subscriptions, 0 through what? Yep. How can you check to see if an array list is empty? Two different ways. You can either use al.isEmpty. That one's pretty succinctly named. That also works for stacks. you want to make sure your stack isn't empty, or you can check size. AL.size equals 0. Either one of those would check to see if the array list is empty or not. And by the way, in your math stack thing, where you were popping values out of the stack, if you entered, an even number, it was supposed to pop 2 values out. One thing you could do is you could check AL.size. Oh, and I forgot the parentheses there. I just lost a point on my exam. You could call AL.size and make sure that it has at least 2 items before you start trying to pop stuff out of it. That would prevent, getting an exception, trying to pop from an empty stack. Which data type is fixed in length once created, arrays or array lists? Arrays, right. Know how to use string.format, which is just like printf. To convert a float, a double, to the format x.xxx, something like that. I should just make it printf though, because that's what we've been using the whole time. But if you're going to do that, it would look something like this. String s is equal to string.format %.3f, end quote, and then whatever the name of the variable was. Like that. It looks just like printf. I may revise the question to ask about printf instead, in which case it would be system.out.printf, quote, %.3f, end quote, comma d. We've talked about the format specifiers. Yes? Please. I want to see lots of heads. Elaine, have we done? Yeah, good. Come in. So just a statement. Java is a pass-by-copy, pass-by-value language, not a pass-by-reference. What does that mean? If you have a function named foo, and it takes a variable, does something with it, and then later on you call foo, and you pass some data into it, like that, x gets a copy of whatever it is. Right, whatever the contents of A23 are, it gets copied into x. X is not equal to that value. They do not point to the same memory space. It gets a copy of it. And that's also true of Python. It's true of C, C++, C#, unless you start using special keywords and symbols to force it to do other things. This language and Python do not support pass-by-reference at all. When you pass something in, it always copies it in there. What is a reference type? Well, we have primitive data types. Give me an example of a primitive data type. Yeah, primitive data types are ints, floats, doubles, whatever. What are reference types? Absolutely everything else. Right? Any class is a reference type. Right? Like string and our point class, our scanner class, array list, those are all called reference types because when you create a new array list, you have a reference to it. About time to go. About past time to go. Come on, just show me the picture. Websites have gotten really annoyed with Google's image search, and so they try to defeat the ability to let you just click on a picture to get what you want. If you're looking at a UML diagram, and it's got a minus sign in front of it, or it's got a plus sign in front of it, does a minus mean that it's private or that it's public?
Seven.
It's private, right. Minus signs mean private. Plus signs mean public. Our rules of thumb are what? You make your data private while you make your functions public, unless you have a good reason to do so otherwise.
And you want to make your data private, but your methods public.
Correct. All right, and then I'm just going to write some notes down here at the bottom. Know how to create an array list of ints or something like that. Know how to add a value to that array list. Know how to write a loop that will print that array list. And how to get the first value of the array list. If you have an array list named A list, would you do it like this? Is that how you get it? Or do you do A list dot get parentheses 0? Which one of those is the correct way of accessing the first element of an array list? The first one is for arrays. The second one is for array lists. So use this syntax for arrays. Use this syntax for array lists. This syntax happens to work for both data types in other languages like C++ where you're allowed to overload operators. But in Java, you have to call the .get method to get it out.
So is this basically what our test is on?
Yeah, I've just gone through the entire exam. We're done. Take the quizzes again, especially if this stuff is not looking familiar. Yeah, I'm going to upload this. That'd be a good idea. Let's do that.